And now we move into the second part of chapter 9, which is coordinates, slopes, and lines. And in my experience, many students don't make the connection about what graphing is. This is all about graphing. And often they just see lines and equations and don't know how to make the connection. So my hope is that by the end of this section, you're able to make a connection between and really explain what a line is and what it represents. And so our terminology, our overview looks like this. We'll talk about the rectangular coordinate system, independent and dependent axes, coordinate pairs, origin, quadrants. We'll talk about slope and specifically lines that have a slope of 0 or no slope, and then positive and negative slopes. We'll then get into lines, talk about the x and y intercepts, talk about parallel and perpendicular lines, and finally, systems of linear equations, a process called substitution, and systems that have one or none or infinitely many solutions. So let's get started. So just like in the previous section, I've got a problem, an opener that I want you to pause the video and try to figure this out. Take a few moments to do that, and we will return to this again actually at the end of the section. Another thing that I want to do is point out a couple tools that I'll be utilizing. These are all in your uh, Blackboard section. One of them is a page of 10 by 12 graphs. So if you are somebody who likes to be working out on paper, you can print these out. I use these in class all the time. And so these are there for you to work with. Another thing we're going to use is a geoboard. And the link to this, we've actually, I think, seen this before in the class. These are fantastic tools that many elementary teachers use to introduce all sorts of concepts, but they work well for a couple things with graphing. And then finally is a website called Desmos. And so Desmos is desmos.com. It's really an online graphing calculator that's incredibly powerful. So I'll be showing you how to do some things with this as well. So let's go ahead and start the conversation. And it's going to start with the idea of what are called rectangular coordinates. And you are probably familiar with graphing the coordinate plane. We'll show that in a minute. In fact, let me get that image. I showed you one of these earlier, these graphs, right? And so this is a coordinate plane. But where did it really come from? So there was a uh, mathematician, Rene Descartes, and he's the person attributed with inventing this. But what it really stems from is we are all familiar with a traditional number line where we have 0 and we count up 1, 2, 3, and eventually we learned earlier that negative numbers were introduced and those would be working left on the number line. And this is great. A number line is great for doing some things, finding where does a specific number lie in relationship to another number. How far apart are these two numbers? We can use number lines for that. We can use it for adding, subtracting, or multiplying and dividing. But all we can do is work directly on the line. It's a one-dimensional tool. Well, eventually, people needed to then start examining space and area. And so they introduced another number line. They just rotated a number line 90 degrees and put it right over top the first one. And they counted up. Think of a thermometer, right? A thermometer measures temperature up and down, positive going up, negative going down. And there's a 0 right in the middle. And so what you have here are two number lines. Two number lines, that's all they are. And what they allow us to do then is examine not just things that lie on the number line, but also points in space off the number line. And they allow us to examine areas and proportional relationships, all sorts of things like that. So the first thing we need to talk about is we have to give these things names. And the horizontal line, we call these axes. This is the x-axis, the x-axis. And the vertical line is the y-axis. So we have x and y. Another important thing to note is that the x-axis always refers to what we call, when we give these things meaning, because a lot of real world situations can be graphed on a coordinate plane like this, and there's always an input and an output. The input is what we call the independent variable. This is the independent variable. The y-axis, the numbers on the y-axis are the output, and those are the dependent variable. And what that means is the information that's provided to you on the y-axis depends on the information in the x-axis. And we'll look at some examples of that later. But just note that the x is independent and the y is dependent. Now, we also need to speak a common language. And so this point that I put out there in space, right there, we have to be able to identify that using a common language. And so what we do is we take that point and we follow it straight down to the x-axis, and we follow it straight over to the y-axis, and we say, where does that point line up? And we have what's called an ordered pair. I'll write this over here, an ordered pair. Or sometimes it's also called a coordinate pair. So ordered pair or a coordinate pair looks like this. It's got parentheses, it's got an x value, and then it's got a y value, and then close the parentheses. The parentheses are just part of the notation for an ordered pair, and they tell us the coordinates of this point, whatever point we're trying to identify. And so when we follow that point straight down to the x-axis and see it lines up with the number 3, that is the first number in our ordered pair. So we would put 3. When we follow it over to the y-axis, this is the second number. And so we put our comma, we put the 2, and then we close that parenthesis. And this ordered pair is the coordinate or the point right there. It tells us all that that's the location of that point. And so that's how we go about identifying points and naming points in space, right? And we're all using the same common language. Now, there is a special point that has a name. So right in the middle where the x and the y axes intersect, do you know the name of that point? Because it has a name. Well, first of all, what's its coordinate? What's the ordered pair that identifies that point? It's 0, 0. And if we think about everything, all the numbers just starting at that point, right? The x-axis starts at that point and goes in both directions. The y-axis starts at that point and goes in both directions. We can say that everything originates from that point. And so we call it the origin. That point is called the origin. Now, when we do draw our axes, our x and y axes, what happens is we divide up the entire space. We call this a flat plane, P-L-A-N-E, coordinate plane. We divide it into 4 regions, and they have names. Actually, they have numbers, and they are called quadrants. So 1, 2, 3, 4, and they're numbered a specific way. Often we write them in Roman numerals, and I'm okay whether you write them in Roman numerals or not, but this is called quadrant 1, and it's because everything in this first quadrant over here, all of the x values and the y values will be positive. So everything over here, it'll be positive and positive. Quadrant 2 is over here. And again, we call this quadrant 1. This is where the majority of real world information occurs, where everything's positive. Quadrant 2 is over here, and all of the x values are negative, and all of the y values are up, so they are positive. Down here is quadrant 3. We just go counterclockwise. 1, 2, 3, 4. Down here, all of the coordinates are negative. The x values are to the left, the y values are down, so both of those numbers are negative. And down here is quadrant 4. And so the x values are all positive to the right, but the y values are all negative going down. And so this is all the information that sort of we can gather from this Cartesian coordinate system. Again, René Descartes, French mathematician who developed this tool. And so the first thing that I'm going to ask you to do is I'm going to put up a picture of some points, and you are going to identify what their coordinates are. So here you will see 4 different coordinates. And so for your first job, it's to state the coordinates, the ordered pair for each of those points. Go ahead and pause and try that. So again, point A, we look, where does it line up with the x-axis and where does it line up with the y-axis? So the x-axis is -5, so that comes first. The y-axis is 2, so that comes second. A is the point -5, 2. Point B lies directly on the y-axis. Always be careful with the numbers on the axes, or the points on the axes. So if we take B and we follow it up to the x-axis, it hits the x-axis at 0. So 0 is the first number. It's lying directly on the y-axis at -5. So this is the point 0, -5. Point C, if we follow it straight down, it hits the x-axis at 1, and the y-axis, if we follow it over, at 7. Point D is 9 on the x-axis, and we follow it over, and it hits the y-axis at 0. So that's the point 9, 0. Now to give another job for you, so I am going to put 4 points, 4 coordinates here, and your job is to graph them using whatever method you want. If you want to sketch a graph or print some of those out that I showed you earlier, plot these points on the graph, and then also indicate which quadrant that they are in. So go ahead and take a moment to do that. So let's start with point A. We'll call this point A right here. Point A is at 4, 3. So the first number is our x-axis, so that's right here. The second number is our y-axis, so that's right here. And so point A belongs right there. Notice it hits the x-axis at 4 and the y-axis at 3. And that is in quadrant 1. The second point, we'll call it point B, is at -2, 4. So -2 on the x, 4 on the y, it belongs right there. That's point B, and it's in quadrant 2. Point C, -6, -5. -6 is our first number, so that's the x value. -5 is the y, so it belongs down here, point C, and that's in quadrant 3. And point D, 3, -5, 3 to the right, 5 down, right there. Point D exists in quadrant 4. So check to make sure that you did graph those appropriately. We have to be able to do that first before we can go on and learn more. So that's an introduction to just the Cartesian coordinate system, how we put our points on our graphs, and how we identify them with our ordered pairs.